Exactly. Low levels. Yeah. Yeah. That exactly Penn Center. I think it's just like a cheap shot. It's a cheap shot to just dismiss something without actually doing the research and investigating. To just say, oh, they're Nazis. Yeah. Yeah. It is a majority in the House. Oh, it's not a big majority? Yeah, no, it's not a big majority, but it is. Okay. Recce Rec. Let's do this one. On a 520 meter... Dude, this is a big fucking hole. That's what she said. Bro, what? Like, most golf courses are like 300 yards. 520 meters? It's huge. A nerve C. Yeah, exactly. Right. Yeah, like, use some critical thinking to actually come up with arguments for why you want to call him a Nazi. Yeah. It's okay to call him a fascist. I understand that. Yeah. He is kind of acting in a fascist nature, right? He just does stuff without asking permission. Billionaire golf court. Yeah, this is a big golf course. 175 meters, 17 degrees to the... Oh, wait, okay. So this is a 2D question, technically. Yes, that's called Logic, Shantrix, which
nice
is a very good class to take. I might actually be tutoring someone in that next quarter. I love when I get clients that want me to teach them courses I've never taken before, but they know that I'm smarter than them and I can learn it quicker than them. So I basically take the course and get paid. And I did that earlier in the year, last year, with the Logic course. I really enjoyed it. I learned a lot about like sentential logic and stuff. 666 yards. Yeah. Okay. Let's say this is the person, right? Let's call this here's the person, and then here's the green, right? And there's a hole in there somewhere. I actually like golf. Does anyone here actually golf? Golfing is fun, I think. I'm not really... I'm good enough to make contact and, hit the ball, but I'm not, like, competitive. I just see it as more of an opportunity to hang out with friends and smoke cigars. But some of you are a little young for that. Only Wii golf? Yeah. I was playing Mario Golf the other day. Apparently there's 2 settings. You can do where you just click to, like, do the hitting thing, or then you actually have to move the remote, and that's, like, much harder. Top Golf!
Nice.
Yes, I do like Top Golf. Okay, let me see if I can actually stream on Discord again without things breaking. No. Damn, we are losing so many frames. Why? Okay. Yeah. It's the size of the hole or the length. It's the length from the golfer. I think he's making a funny comment about that one. Okay. It would be a very big thing. Okay. It travels 175 meters, 17 degrees to the right of the direct. Oh, interesting. Okay. So we're gonna say it does this first. 17 degrees to the right. So 17 degrees to the right means 73 degrees this way, right? Okay. Let's make it realistic. Okay. So it does that at 175. And then this is 17 degrees. And then it flies 15 degrees further to the right. Okay. So when this happens, I like to draw another coordinate system. Kind of what I do. Makes life easy for me. Like, I'm just gonna do this. Calculate the mass of the sun. Okay, there we go. So I'm gonna draw this little coordinate system, and then I know it does. Let's use a different color. Let's use pink. And it's gonna do that. They said 15 degrees further to the right, but only travels 150 meters. Okay, so that's gonna be 75, I guess. This is very sultry music. You're listening to Late Night Algebra with Dr. Gold. This 2025 classic was brought to you by PBS. Gold After Dark. Okay. Alright, then this is 15 degrees. Yes. Okay, cool. And now they say how far to the nearest meter is the golf ball from the flag. Oh, so now we gotta go figure out this. Wow. They want to know this. They're like, how far is this? Well, let's make this a little bit bigger. Question mark. Is this what Tiger Woods does in his free time? Yeah. That or apparently drink vodka and try to drive on Xanax. Poor Tiger Woods. I think he had his accident down the street from me. He was in Palos Verdes, right? Okay. Ayush, Recce Rec, have you learned vectors before? Do you know how vectors work? Is that something in your vocabulary yet? Don't think so? Okay. So, one way to do this... Yeah. You will learn this eventually. This is called a vector. Because it has what's known as a length to it, but it also has a direction. This 17 degrees. You'll see it. Little spoiler. The reason why that's important is because even though this thing travels 175 degrees in this direction, the directions we care about is how up down it goes and how left right it goes. So 15 degrees to the further to right doesn't mean 32 degrees total. Yeah. Get out. Is he coming into the room on you? I mean, it is 32 degrees technically from here, Jeff. You are right, but the issue is we're not doing the same distances, right? Because this amount is 150. Yeah. Okay. So here. Oh, this is way too big. 150. Yeah. Okay. So what we're gonna do is I'm gonna take this first leg, the brown amount, and I notice that this makes a right triangle. Okay. Such that I could break down the amount that this golf ball travels into the amount up it travels and the amount right that it travels. And I know at the end of the day, I need the total amount of left-right going from here to here to be 0. And I need the total amount of up-down to be a positive 520. Yeah. So this is technically called vector decomposition. But the way to do that is we're going to break up this brown triangle into 2 components, which I'm going to use some different colors. I'm going to use light blue here. I'm going to say that this right here is what we're going to call the Y component. And then this is going to be, let's use a different, let's use red. Let's use red. Okay. We're going to call this the X component. Okay. Recce. Now that I have this, all right, how do I figure out from this first 175 what the Y component of it is? How do I figure out? So it's going 175 at 17 degrees to the right. How do I figure out how much up it went? Adjacent over opposite? Not quite. Trig, yes. Trig it is. This is why we learn all the stuff. The sine law. Close. What's up, Raven? Yeah, so there are 3. There are 3 we learned, right? We learned this whole like SOHCAHTOA thing, right? SOHCAHTOA. And This is opposite over hypotenuse. This is adjacent over hypotenuse. And then this is opposite over adjacent, right? Yeah, good job, Rainey. Yep. What I like to always do is see in this triangle, what am I looking for and what do I have? Breaking up the scenery, blowing my mind. Signs. What song is this from, Jeff? So in this triangle with this angle, what is this blue thing? Is this a hypotenuse? Is this an opposite or is this an adjacent? What is it? Oh, it's just called sines? Yeah. We have a calculator later we can use. We got the gold calculator. Yes, the y is adjacent. Very good. This is adjacent. Yeah, and you know, learn along with us, you know, even if, you know, if you get things wrong, it's cool. Like, try. This is adjacent. Okay. This is going to be opposite. How I like to think about this, guys, if this is my angle right here, the opposite is opposite of it. It's like if you were just like to shoot something at it, you know? Like, what would you hit? If I were to come straight out of the gate of this angle, right, I would hit this side. That's the opposite. This side right here is the hypotenuse. Shooting at my ops. Yeah, exactly. Pew, pew, pew. Yeah. This is the hypotenuse. The hypotenuse is always the longest side, first off. And it's also the side that is opposite of the 90-degree angle. You see how this up, down, and left, right makes a 90-degree angle? That's because technically, we'll learn this later, but this is called that they're orthogonal. Orthogonal means like they make a 90-degree angle. Yeah, you're good. Yeah, no, my bad. You're fine, dude. Like, yeah. I'm glad you're interacting. That's the only way you learn. Right. So, this is the adjacent, right? And the other thing we know the length of the hypotenuse. So, based on that, Reki, which one of these trig functions am I going to use to try to figure this one out? Been a month since I touched math. Well, now you're touching math today.
That's dope.
Yeah, math is dope. Tangent. Not quite.
No.
Remember, again, Reki. We have this. We have the adjacent that we're looking for. But we don't, thanks, Raven. Yes, very good. Yes. Ka, Shantrix, good. Yes. Hypotenuse. I want the hypotenuse. So adjacent and hypotenuse is this one. Okay, it's the cosine. All right. The next step is to write out this trig thing as an equation with like a ratio, because that'll help you figure out how to do things, okay? So what I'm going to do is I'm going to write out the cosine for this angle. So I'm going to say cosine of 17 degrees is equal to the adjacent over the hypotenuse. And now the adjacent, that is y. Okay? And then the hypotenuse is 175. I think you're right, Rainey. So once I have this, okay, now I can solve for what this y is by using algebra. All right? So what I like to do is then multiply both sides by 175. Okay? So this goes away. And then you have that the 175 cosine of 17 degrees is equal to y. Well, Reki, you should keep things as decimals here. You shouldn't round yet. Round at the end. Because if you start rounding shit up over here, it's going to start messing up at the end. Round stuff at the end. Yeah. Like, error propagates. Okay. Now, here's an interesting thing. Let's say, for instance, just for this is an algebra thing I see students do wrong all the time. Let's say you have the adjacent, but you don't have the hypotenuse. Let's say, for instance, I knew this was like 168, and I didn't know what the hypotenuse was, right? Let's say like we're solving for the hypotenuse. How do you get the hypotenuse here? What's the algebra? I see students all the time say like, oh, let me just divide by 168. Let me divide by 168. Or they'll even say multiply by 168, and I'm just like, it's not correct. Yeah. Good. Yes, Raven. Yeah. So let me show you how you do that. Just, yes. Thinking wise, what I like to do is I like to make this a over 1. And now you have what I think you guys call like the butterfly method. You have an equal sign and you have just 2 fractions. This is nice. When you have this, you can always swap what the diagonals are on things, okay? So I can swap this with this. I can put this over here and I can put this down here. What's up? Yeah, good to see you, Zach. Nice. Happy Monday, man. Oh, did you guys not have linear algebra this morning? I think I didn't. I saw Famished actually streamed actually today. Yeah, shout out to Zachy Poos. Good to see you, Zach. Hope you're feeling better. I know you're feeling kind of sick last week. Something's been going around. One of my friends was like super sick. Some person at the gym today, I was getting out of the sauna and we were just chatting. And he's like, yeah, dude, I love the sauna here. It stops me from getting sick. And I said, oh, yeah. He says, yeah, anytime I start feeling like I'm going to get sick, I just go to the sauna. And then it runs out of my system in 24 hours and I'm great. I'm like, all right, cool, dude. But we're both next to each other right now. So am I going to get sick? It's like information I didn't want you to share with me. Anyways. Oh, mental health day? I feel for you, Pen. Pen, my DMs are always open if you want to like talk about. I know we had some fun mental health to deal with on Saturday, but is it a continuation of that? Are there other chat logs or chat channels I'm missing out on? Yeah, slide into those DMs, man. You don't have to be a what is it? A Patreon or OnlyFans or something? Actual feet. Where's Sensation, dude? Sensation. We start doing actual feet. Okay. So when this happens, guys, the cool thing here is that I can move this up to here, and I can just move this down to here. This is a really nice algebra trick. I love doing this trick, and it helps out so much because now I have something exactly like you guys were saying. Yeah. Super easy. Yeah. So yeah, just heads up. I see students all the time do the wrong thing. I want to teach you guys to do the right thing. You could technically divide both sides by 168. But then this kind of like sucks. Because then you get this is equal to 1 over the hypotenuse. And for whatever reason, students don't know that if you just flip this, you can flip this. So if you put this like flipsy flipsy, and you flipsy flipsy this, that's like legal. And so that gets you 168 over cosine of 17 degrees equals the hypotenuse. Exactly. Yes. Good. Thanks, guys. You guys. 1 over hypotenuse. I'm amazed you can spell that. I'm the worst at spelling hypotenuse. Okay. So we got a number for this one. Right? Yes. This was equal to 175 cosine of 17 degrees. Ooh, yes, trivia night. That's gonna be on Pi Day, right? March 14th. That's gonna be here before he knows it, dude. January was a fucking memory hole. I don't even know what happened with January. So I'm pretty sure February will go by pretty quickly as well. What do I do if I feel I'm too dumb for math? You're never too dumb for math. Don't worry. I sometimes have bad days where I feel like I can't math. Like the math isn't mathing. Usually I go eat a cookie or something. Or go meditate. It helps me out a bunch. Yeah. Oh no, Recky Wreck. What happened? Why'd you get timed out? Oh. Okay. Lamau. Oh, we typed too many emotes? Yeah, don't spam the chat. The auto mod will go get you. Or one of my mods will get you. Cookie it is. Yeah.
Nice.
If you're bad at meditating, I was too for a while. And it really helped. I have a friend who's very big in that space. And she does like a guided meditation tape, which I find if like someone's telling me like, oh, focus on your brain, now focus on this, focus on this. I stop thinking about, oh, you know, did I leave the dishwasher running or something? That's the whole point of meditating. What's up, Recky? Yeah, Recky, talk in Discord. Yeah, you're okay. All right, here we go. All right, so if this is 175 cosine of 17 degrees and we want to figure out the x component, This is now the opposite and the hypotenuse. And opposite and hypotenuse is sine. So you could write out the sine of 17 degrees is equal to the opposite over the hypotenuse, which is equal to x over 175. Yeah. Bro migrated to Discord. He's like, I'm safe here. Yeah. You can spam emojis, I think, in Discord. I don't think I have protections against that yet. Someone wants you substituted equals MC squared in the Pythagorean theorem. Really? That's too funny. Anyways, moves over here, right? And you get the x is 175 sine of 17. I want to show you guys, like, kind of a cool trick here. This will help you out in physics and stuff, because we use in physics all the time. We're breaking up vectors or hypotenuse things, hypotenae, into x and y components. If you figure out one of the sides is cosine, the other one is always sine. And vice versa. If this one is sine, then this one would be cosine. I think the formal math thing is that sine and cosine are orthogonal to one another. I know they're pi over 2 from each other, so that kind of makes sense. So yeah, all right, cool. All right, so we got that. We're going to do a similar technique on this one, okay? I'm just going to like kind of skip ahead just to save some time. So for this one, again, we have the y, we have the x, and we can figure out what each of those are. This one, oh, this is 150, not 15. Nope. Oops. Make that smaller. Okay. Here we're going to get that. Oh, that's too thick. Oh, damn. She's thick, boy. This is 150 cosine of 15 degrees. And then the x here is 150 sine of 15 degrees. Complementary. Oh, that is true. Yes, cosine squared plus sine squared equals 1. Wait, does that make them orthogonal? Is that how that works? You have to show me the proof for that one. Okay, cool. So, now that I have x and y components for each of these, I'm going to add these up to figure out what's the overall distance in x that the golf ball traveled and what's the overall distance in y, like the total so far. In math land, this is called finding the resultant vector. Because what you're doing is you're taking two vectors, this is a vector, and then this is a vector, and you're adding them together to make a super vector. Okay. Does that make sense, Ayush? Yeah. Oh, yes. Okay, okay. Wait, cosine nx, sine of mx. Wait. You mean one of those is a sine, Jeff, right? Okay. Okay, so adding these all up, right? We have in the x component, I like to make like little columns for these things, right? X and y. This is going to be 175 sine of 17 degrees. This is 175 cosine of 17 degrees. Too many things. And then this is 150 sine of 15 degrees. And this is 150 cosine of 15 degrees. And then we're going to get a total. Yes, sine and cosine over a single period, yeah. Put the fries in the bag. Yeah, I got you, dude. We're having fun. It's Monday. I actually started doing this on my TikTok videos because I realized I'm reaching the age where I don't have enough time to brain rot and figure out what all the memes are or like what you kids say these days. So I'll write my scripts now for my TikToks, and then I'll tell ChatGPT to rewrite them in Gen Z slang, and then I take the parts which I think are appropriate, you know, not like going overboard. I don't want to sound like, you know, older people will know this, but it's the Steve Buscemi meme from 30 Rock, where he's like, "How do you do, fellow kids?" I don't want to be this guy, even though some people say I kind of look like him. So I try to at least research the slang you guys use to see which ones are what's like appropriate, but Skibbity Ohio. Yeah, that's it. The second you start saying Skibbity Ohio, it's just like too much. That's like Gen Alpha, I feel like. Okay, so if I add these up, I get 89.98. That's pretty much 90. We'll call that 90. That's okay. And then I can take these, I can replace it. No, replace it with the cosines. Shank trying to rizz me up. Yeah, there you go. I used to say gas me up. I don't know if they use that term anymore. Like, if you want to... They call it meat riding, too. That's the other thing they call it now. Like, if you're... It's kind of like what we would say, like, kissing ass or, like, sucking up. They call it meat riding. I was like, wow, that's excessive. Anyways, 312.24. Okay, cool. So that's the total X. That's the total Y. And now... So that's how far the ball has traveled when it went from here, you know... over to here. We need it to bounce back in and get over to here. So what I like to say is I need another vector or another trajectory. Here, let me copy all of this. Let me put it here. Okay. So this is the running tally so far is what it is. But then I need another amount, another vector, such that my total in the x direction is 0, right? Because we want it to go straight. You don't want it, you don't want any direction in x. It wants to go just straight towards the hole. And then in the y direction, I need it to go 520. Hey, what's up, fam? You're just about to learn about meat riding with Dr. Gold. On tonight's episode of Office Hours, got some smooth integrals and closed contours for you guys. Followed by meat riding. I feel dirty. I don't feel so good, Mr. Stark. Okay. So this is... Okay, so this was me... This was like hit number 1. This was hit number 2. And then this is the total. Okay, and then we need hit number 3. And then we need what I call like the total. Yeah, I'm not sure what we're doing anymore. So let's recap. This has been a kind of a long question, but I've had some fun. We've been strolling through it. So we have ball, right? Ball's right here. Ball got hit once to get to here. This is what happened after it got hit once. Then it got hit again. That's what happened to it. And then this number is the total of where the ball is now from the start. So after getting hit twice, the ball is here. I need the ball to eventually get over here. It's like a game, actually, is what it's like, right? Exactly. It only wants a distance, which is cool. So we'll get that. So what I've done is I've kind of set up a table here, right? Where I've broken down in the left, right, the X direction, and the Y direction, up, down, how far the ball has gone after every hit. So after hit 1, it did this. And then hit 2 contributed this much more to then get here. This is the total after hit 1 and hit 2. We need a third hit, a third putt, to get this thing to have a total change in its position of 0 in the X direction, because we want it to go straight, and I need it to go 520 up, so in the Y direction. Yeah. Yeah, Fembox. I think someone bought the ticker. I forget who it was. Someone bought the ticker for today, so that's what's on the ticker. It would be, yeah. Oh, it was Famished? Yeah, Famished bought it, yeah. Ayush's having a great time with all the emojis in Discord because I'm not gonna... Bitcoin, Bondcoin, yes, Shantrix. Dude, what's going on in my chat over there? Okay. Alright. So, if after hit 1 and 2, it's traveled 90 in the X direction, but I need it to overall travel 0...
This means that hit number 3 needs to be negative 90. Okay. Now, here, Reiki. How far do I need it to be in Y? It's a question for you now. How far do I need it to be in the Y direction for my third hit in order for it to get to the T? Or is it called the T? No, T's where you hit it from. Hit to the hole. Yeah, Zach got the baby voice too.
So let's see. After the 2 hits, no. After the 2 hits, it's traveled 312 in the Y direction. That's the total amount it's gone up. I need it to go up to 520. That's the total, right? The total. The ball, right? The ball starts here. It goes here. Then it goes here. And so at this point, it's gone like 312. Exactly. So in order to figure out how much further it needs to go, we're just going to do 520 minus that 312. Okay? So we're going to do this minus this. So pull out the calculator again. We can do 512. Diagram is most definitely not to scale. No. 199.76. Yeah. Yeah, this diagram is a catfish. If this diagram was a dating profile, you know. He's back after 10 minutes. Okay, great. Okay, cool. Okay, so then this is what we need to do. We need to figure out the distance of this third hit, okay? So what I like to do, once I have the components, is then return this into a triangle, where again, we need the X direction to be negative 90. So let's draw that out. What color do we use for X? We use red. Let's use red. So I need it to go this way, negative 90, and then I need it to go 199.76 in the up direction. So that's going to be this. Okay? So now we have some numbers for things, right? This needs to be 199.76. This needs to be 90. So then the total distance that this golf ball needs to travel is this. Did I type 512? Oh my god, I did. Thank you. My bizzles. Good catch there, dude. 207.78, yes. Alright, let's change that. Thank you. Save for Jeff. Jeff, you get a saves. More saves for Jeff's. Well, I'm not the math major, I'm a physics major. Yeah. Physics is my game. I LARP pretty well as a math guy, because a lot of math is needed for physics. Yeah. The what writing? I love meat writing. God damn. I teach a lot of math. No, for sure. But my degree is in physics. If we want to get technical, I took a lot of math, anyways. Dr. Gold, baby voice. Oh, back. I like that. That's funny. That's a great emoji there, Shantrix. Okay, so in order to figure this out, right, the total distance. Now what we're gonna do is the Pythagorean theorem. Yeah. Zach is our resident math PhD. He is. I believe Penn Center has a PhD in math too, right? Or is it like applied math? Oh, hell yeah, dude. Famished. Yeah, if you want to teach yourself physics, I have a textbook you can use. Penn Center did something earlier last year, I think, where he was trying to do a streams of teaching himself physics, but he picked up the most, like, nightmare sadistic textbook. It was, I would say, an upper division physics textbook he was teaching himself mechanics with, and, like, even I, looking at those questions, I'm like, bro, that's a struggle.
Oh, no.
Yeah.
No.
Yeah, so you don't want to do that. Yeah. So, yeah, if Famished, if you want, send me a DM, dude. I'll send you my the textbook I use for mechanics. And actually, funny enough, if I think it's happening, but I'm not saying anything until I sign the paperwork. But if I thanks, Rainey. If I end up teaching at UCLA, it will be a mechanics course for pre-meds, and I think I'm streaming those lectures, so maybe I'll just restream them on Twitch. I wonder if I'm allowed to do that. I don't know. Maybe. Okay. So. Yeah, Nito. Yeah, right? Yeah. I have a class assigned to me. It's a lecturer, Zach. So, you know, it's not like a full professorship, but it's cool. I have a class assigned. I'm waiting for the dean to approve it or something, which I don't know, dude. Trump's president. Anything's possible. So I don't know if it's going to get rejected or not, but I feel like it's getting accepted. Okay, so to get the total distance, this is C. We can do the Pythagorean theorem. So that's 207.76 squared plus 90 squared is equal to C squared. Yeah, I'll DM. Yeah, send me a DM and so I remember, and I'll give it to you. If you wanted to do it on your stream, like that's a fun thing to do. I'd be happy to help you with it, man. Like pop in, and I was doing that with Penn Center for a bit. I popped in like once or twice into his voice chat to give him some assistance, because Penn Center's a very smart guy, especially math. But some of the questions that were getting asked out of that textbook were pretty ridiculous. Like, yes, you can brute force it with the math, but there's so much funny intuition you have to develop in physics in order to do them. Trump hat next stream. Dude, they do have a nice black one, and black and gold one. I kind of like it. If someone bought it for me, I would wear it. At least for one stream. Anyways. Okay, cool. So, I think C is 226.41. Yeah. Is that what you got, Reiki Rec? That's the total distance, is what that is. Or how far it is from the flag. Oh, you stream in the co-working space? Oh, round down. Oh, sorry, nearest meter. Yes, nearest meter. Yep. Oh, so that should be 226. Yeah, 226. I just stream in Just Talking because it has the most people in it. And, you know, I'm kind of hoping people get tired of the thirst traps and the feet pics in the other streamers in that category. Yeah, just chatting. That's what I used to stream in math and science, but Sensation's actually the one that suggested to me. He's like, hey, you should try just chatting. The amount of viewers there is insane. I was like, yeah, okay, cool. Good job. Thanks, Chantrix, for helping on that one. Or did I say just talking? Yeah, my bad. Anyways, okay, cool. I think it's the answer. Good job. Speaking of Trump. Okay, cool. Wait, there we go. That's what I want. Maybe try hot tubs. We did a hot tub stream at one point. Like, very early on. I don't know if I did it on Actual Education. I think I did it with someone else's channel, but it was, his name is Bon Me Boy. He's actually the reason we have Bond coins and why they're named after Bond. Yeah. We did a hot tub stream at some point. Yeah. I wonder if I can find it. One sec. Let me see if he still have his stuff. Bon Me Boy 1? I think that was his name. Oh, maybe he got rid of it? Bon Me Boy? Man. Bon, what's your... He's not watching right now, but I'll have to find it at some point. Wait, it was the same as this thing here. One second. Yeah, Bon Me Boy 1. Okay. Nope. You know what happened? He got a big corporate job, and I bet he scrubbed everything from the internet. That's one thing I don't want to do, man. I don't want to get a job where I have to start scrubbing like this. Because someone's going to get mad that I said, as Pencer said, right, the N-word. I said Nazi. You're not allowed to say Nazi apparently now. I don't know. Mary did one with his avatar. Yeah, no, this was us in a hot tub. I think someone gave us like 5,000 bits for like some feet action or something. It's very interesting. It's like there's a lot of degeneracy on the internet. Do they even still allow hot tubs as a category? Like if I go to browse here. See, this is why I talked about just chatting, dude. It's the most. 430K. This is huge. Music. Let me see if hot tubs is a thing. No, they got rid of it. Yeah, they got rid of hot tubs. They have chess though. That's fun. Sports. Yeah, okay. I don't know. Twitch is going all over the place with stuff. What up, YouTube gang? Yeah, Gaming Wizard and Poly again. Okay, like polynomials again. Chess blew up during the pandemic. Oh, it is. Oh, it is. Oh, it is on there. Oh. Ish. Pools, hot tubs, and beaches. Wow, but they're all like. Do you see how they're all taken out for like may contain sexual themes? May contain sexual themes. Wow. Yeah, they're starting to get these people now. Yeah. Jeff knows. Yeah. Jeff's meat riding the hot tub streams. All right, here. Let's see if Ace is here. I think this is a good one. Oh, we're doing quadratics. Okay, cool. What the heck have I been doing math the whole time, right? There's hot tubs to watch. I was messing around with OneNote earlier and the option to add equations. Oh, that's cool. Does it have like a latex thing built in? That would be super handy. I'm happy. I've been using this platform. It's called Group World. I've been using it since probably 2016, 2015. So I'm just familiar with it, but there are some better apps out there for sure. LaTeX would be cool, but I don't know. Coding LaTeX still just takes time. I can just draw it out faster. Let's see if Ace is around. I'll do Ace questions if he's here. He's in the chat. I watch those stream for the articles. Dude, bro, what's that from? I watch it for the articles. Oh, that's the Playboy joke, right? I read Playboy for the articles. They probably do have some decent articles in there, though. I don't have a digital tablet. Yeah, no, this is... And, bro, Famish, these are very cheap. Not very expensive. If you want to know. You can even get, like, some Chinese knockoffs for real cheap. Amazon. I think I use the Wacom Intuos. Is the one I use. Yeah, here we go. It's $50. Right? You can get it in pistachio. I think I use the medium-sized one. It's on sale. The small one is. Look, the small one's usually $100. It's knocked down to 50. That's quite a deal. I might just... I have one of these that I also use for when I travel to go tutor and I need to draw things. Dumb question. What's a vertex used for? No, that's not a dumb question. That's a great question, actually. Yeah. Dude, it's on sale. Go get it. I've used the Chinese knockoff ones, like the Temu ones. They just break quicker. This Wacom I've been using probably for a solid 2 years. Still works. So, Raven was asking, what is a vertex used for? So, a vertex is used for a parabola. And parabolas look like this. They can either look something like this or something like this. I like to say it's the happy face and the sad face. It's like sad. Happy. Okay. Why we use them, okay, is that the vertex of a parabola describes this, which for an upside down parabola, this describes the max. Okay, this is a vertex. For a regular parabola, this is the regular one, because whatever, the variable here is positive. This vertex here is called the minimum. There's also a very cool property. Nice, Ace. We'll do yours soon. Oh, we're doing yours now. I'm just explaining why vertex is important. Because a lot of times, data or stuff that you're observing in the world will follow one of these patterns. It'll follow this like trend as a function. And figuring out where the most of something or where the least of something is all about figuring out where the vertex is. There's also a very cool property about vertices, a vertex, is that if you have a horizontal line, okay, a horizontal line will hit a parabola in 2 points everywhere, except at the vertex. At the vertex, it only hits this curve once, and it's right here. So this comes up in math challenge questions where they'll say, like, where's there only one solution or something, and this is usually what it is. Because this is usually y equals to something, and then this is y is equal to, I don't know, like negative x squared plus 6 or something. And you want to know where this hits this with only one solution. It's at the vertex. Yeah, you're right, Jeff. Yeah, it can also hit it 0 times. I mean, but if it's going to hit the parabola, it'll always hit it twice. Unless it hits the vertex. Then it only hits it once, and then you can also just not hit it. And then this is also called the tangent line to the curve, which is a horizontal line. It's pretty cool. Okay, so yeah, does that help out, Raven, a little bit? Like, I love it when people ask, like, why the fuck are we learning this? Like, yes, it's because it gets used for things like this all the time. Okay. All right, but it says, if the vertex of a quadratic function is this. Okay, so this is the point. State the equation of the function in standard form, which is this. Okay. There's actually 2 answers to this, Aced. Why are there 2 answers to this? Can I just draw this just for a second? Okay. So I'm at -4. Positive 1/2. There's a family of answer. Family. Well, they say it's a quadratic function. So it has to be a parabola, right? Quadratic means that the highest power it goes up to is x squared, and that's usually a parabola. All parabolas are quadratic, but are all quadratics not parabolas? Oh, you're so fucking right, Jeff. Thank you.
That's dope.
Jeff, you get another save. I forgot that parabolas come in all shapes and sizes, like God's children. Yes, because if this is interesting what Jeff is saying. If this is the vertex, -4, 1/2, DEI parabolas. Stop. You could have a parabola that looks like this. You could have a parabola that looks like this. You could have a parabola that looks like this. You could have a parabola that looks like this. There's an infinite number of parabolas you can draw with various widths and like whether they're going up or down that will also contain this point as the vertex. So interesting. So yeah, aced. We need a little bit more information here, okay? They gave us the vertex of a quadratic function. Cool, I like that. But they'd have to give you something else in order to do this. So I'm just going to pretend what they usually do in these types of questions. They'll say if the vertex of the function is this and it passes through a point. Let's say it passes through -2 comma, I don't know. What do we want to do? Let's just say 5/2. They didn't do that? Well, they kind of have to. Pi? That's going to just make things ugly. Sure, whatever, fine. And it passes through -2 pi. Okay, Jeff, challenge accepted, bro. How can we write it out? Right. So here you have the vertex, okay? And then we know it also passes through the point here, -2 pi, which is like up here, okay? This is -2 comma pi, all right? So first off, we know that this parabola would look something like this, okay? See how it has a vertex here and it passes through this point? But how do we do this? Good question. So what I like to do, rather than memorize, there's a way to memorize this using the standard form notation for like what the vertex is. Let me see real quick. Yeah. See how he gives you a point, though? He gives you a point. You see how he says using 0, 25 over 2? This is a point. So, yeah. Technically cheating. But we'll do it with -2 and pi. Just because I want a challenge. Okay. All right. I like to write things in vertex form first, which I think is what your teacher does. Yes, it looks like that's what your teacher does. So vertex form, this is standard form. Standard form is just a, b, c, then x squared x, and this is technically x to the 0. Y is equal to a, x minus h squared plus b, I think. This is how I like to write out the equation of a parabola. This is called vertex form. And then all we're going to do is then later multiply all this stuff out to make it a nice polynomial, which is standard form. So, what I can do is in this form... Oh, sorry, this is plus k. H comma k is equal to the vertex, all right? So if we were to plug that in, I would say that y is equal to a, and then we would say x minus h is the x coordinate of the vertex, which is -4. So minus -4 is +4 squared, and then plus k. K is the y coordinate of the vertex. It's like how high, how up and down the vertex is, which that's at 1/2. So I'm going to add 1/2. Okay? Now we have the equation of the infinite number of parabolas that would pass through this as the vertex. In order to figure out what this a... Do you see how this a is a variable? We don't know what this thing is. This is what determines whether the parabola points up or points down. If a is positive, it points up. If it's negative, it points down. And then if a is very large, then it becomes a very skinny parabola. If a is a very small fraction, like 1/10 or like 1/20th, then it becomes a very fat fraction. So in order to determine this, though, we have to plug in a point to figure out what this is. This is very similar to, let's say, for instance, you have like y equals mx plus b. You know how usually you take whatever to figure out the slope? Like if you have 2 points, you can figure out, oh, cool, the slope is 3. And then the way to figure out what b is to plug a point in for x and y, and then that allows you to solve for b. It's the same technique, same strat, just different vibe. So what I'm going to do is I'm going to plug in Jeff's like clusterfuck of a point, -2 comma pi, and we'll see what we get. So if I plug in pi for y, right? Then we get this is equal to a. The x coordinate is -2, so I'm going to say -2 plus 4 squared plus 1/2. And let's see what we get. So -2 plus 4 is 2. 2 squared is 4. So I get pi is equal to 4a plus 1/2. Subtract 1/2. Pi minus 1/2 is equal to 4a. Divide by 4. You get a is equal to pi over 4 minus 1/8. Or another way to write this would be 2 pi minus 1 over 8. Just one of those days, Jeff. Yeah, some days it's just too easy. Okay, so 2 pi minus 1 over 8, that's equal to a. Here I just combine fractions. You just like 2 times 2 times 2 is what we do. So that's 2 pi over 8. Okay, so now I plug this back in. Let's see what we get. So now I have y is equal to 2 pi minus 1 over 8. And then this is x plus 4 squared plus 1/2. The last step is to just kind of like multiply everything out and start grouping shit. So this, from before, this is why I say math is all related, right? Remember, we did this earlier, yeah? Remember this? A plus b squared is a squared plus 2ab plus b squared. This comes up again. Because I have this, right? A plus b squared this whole part here is going to become x squared plus 8x plus 16. And then we have a plus 1/2 here. And then we have this 2 pi minus 1 over 8. Okay. Now, some students will make the mistake of they want to add this to this right away.
No.
Can't do that. We still have this ugly stepsister, you know, chilling outside being like, no, you can't go to the ball, Cinderella. So this needs to multiply through first. And then we can add the 1/2. Because remember from PEMDAS, you got to do multiplication first before you can do addition. So if I multiply this through, I get 2 pi minus 1 over 8 x squared. Actually, I should put this in parentheses. X squared. Plus 8. Oh, the 8 and 8 cancels. That's nice at least. Love that. And this is going to be 2 pi minus 1 x. And then we're going to say plus 16 times this. That's just going to put a 2 on top. So that's going to be 2 times 2 pi minus 1 plus 1/2. So the last bit is to resolve this, which we can do by just making this a 4 over 2. Okay. And now this becomes 8 pi minus 4 plus 1 all over 2, which is equal to, oh man, what is that? 8 pi minus 3 over 2. Okay, cool. So, yes, then your final answer is, I'm going to copy paste this because I'm lazy. 2 pi minus 1 over 8 x squared plus 2 pi minus 1 x plus 8 pi minus 3 over 2. And then this is standard form. Standard form just needs a number, a single number in front of x squared, or single expression in front of x squared, plus another expression in front of x, plus another expression in front of nothing, no x's. And so this is what you get. Nice. Good job.
Well done! Well done!
Yeah, good. That's cool, Ace, you're learning that, dude. That's a useful thing to know in math land. All right, let's see. Next up is going to be a Darsh, I think. Ace, what science classes are you taking this semester, this year? Are you still taking physics? Are you moving towards E&M? Like, I helped you out with mechanics, I remember, last year. I'm wondering if you're doing E&M this year. You're doing advanced functions. Yeah, they call this thing advanced functions. Advanced functions, I think, is just pre-calc, right? Oh, onto chem. Okay, cool. Well, yeah, feel free to ask chem questions. I love doing chem. Chem's like my second love. Well, maybe my third. I think it's like physics, math, chem, and then stats. If I had to rank... I did help you out with E&M? Okay, cool. I forget. I do many things. Yeah, I love chem. Big fan of chem. I was teaching someone chem last night. Chemistry is cool because it's this nice hybrid between physics and biology. You know, it's related to more of the building blocks of life because you deal with like molecules and things. But it's not so memorizey as biology is because there's still a fair amount of math that's used in chemistry. Like, when you're doing titrations and stuff. There's a lot of cool stuff. Yeah. What's up, Obi? Shout out to Obi. Love Obi. I saw you were playing a game yesterday, Obi. Was it a pachinko game? I feel like it looked like it was one. My friends in Fed have been doing tours in different departments. It's been called diversity tours for decades. They're not allowed to call it anymore? Yeah. This is where I don't like this just instantly banning anything that has the word diversity in it. Because, like, diversity is cool. I feel like this is a very diverse thing. We have such a variety of characters and backgrounds, both in Discord and on the Twitch. Yeah. Yeah, call it interdisciplinary. Yeah, there you go. Yeah. You can't call it DEI if it's chemistry to physics to math, right? There's no race involved there. Well, I mean, I guess sometimes there is, certain. They're doing with malicious compliance and calling it the do other story.
Good job.
That's hilarious, dude. Okay. Aduki, Adarsh. Is this growth, decay, or neither? This blue graph. It's pretty cool. I wonder what this is actually a graph of. Like, I wonder if we could come up with the equation of this graph. I think it's like -1/x plus like 4 or something. I feel like it's growth too. I think it is too. Oh, it's negative e to the x with a little bit of a shift probably, right? Yeah, give or take. Cool. Yeah, it's growth. Because what happens is, as you go from left to right, just see what happens to the function, okay? So, as I go left to right, this function goes up, like following the blue line. Probably -2 to the x. You mean like this? -2 to the x, right? It looks like it hits 3 at 0, so I feel like it's like -3 to the x, maybe? Wait, oh, it needs to be this plus 4, I think. I think this is the graph. What's the multiplier, yeah. So, yes, this is growth. I see an asymptote at x equals -2. Oh, I do as well. Yeah, is it? I think they would have drawn a line there, Jeff, though. Do you see how they did this one here? Yeah, I think it just blows up there. But I don't think it's an asymptote. I think they would have done this. They should have drawn a line if it's an asymptote. Yeah, it's off the graph, man. It's actually kind of cool. We could debug this because I see 2 points, right? I see -1, 0, and then I see 0, 3. So with these 2 points, you could try to fit an exponential, and then it's asymptotic. So that's actually a good question. Yeah, where is the asymptote here? Where's the only asymptote, Adarsh, that's marked out? And then tell me what type of asymptote that is. Good. Very good. Y equals 4. Yeah. Very good, guys. Yeah, y equals 4. And that's a horizontal asymptote. Which, this could help with us trying to figure out what this equation is. Because in order for there to be a horizontal asymptote, if this was a polynomial, right, we would need the power on the top to equal the power on the bottom in order for there to be a horizontal asymptote that is non-zero. What's up, Endar? Endar already has it. He says it's -2 to the -2x plus 4. Hey, you know what we're going to do? Here's what we're going to do. We're going to compete. We're going to compete with this. We're going to take these bets. I'm going to see which one fits better. So we got some submissions so far. Well, no, we're going to graph it afterwards, Jeff. I don't know how to start polls, but if you're a mod, you can go start a poll. I should make you a mod, Obi. I don't know why I haven't at this point. What do I do? Can I do it from here? I'll do it after the stream. But Jeff, you're a mod. You can start a poll. Okay. Yes. So asymptote at y equals 4, which in order for that to happen, if this was a polynomial, we'd have to have something like 4x to the third over 1x to the third plus like blah, 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 plus blah, blah, blah. Because you always look at the highest power on the top and the bottom. Oh. Okay, so what are the submissions? What type in the chat which one? I have Endar's and I have Jeff's. Obi, what? -3 to the no, you got to give us that something though. Cuz I'm going to put it into Desmos and we're going to see who wins. Who gets the lower R squared value? Okay, cool. All right. What's the domain of this, guys? What's the domain? No, you're not dumb for this. I mean, again, you're not expected to do this part. This is just the math chads like going at it. They're trying to flex their math brain at each other, which I'm cool with. Like I welcome competition. I think it's fun. And I think it's also a great thing to encourage participation in math at all levels. Good. Negative infinity to infinity. Correct. Yeah. So the domain describes like what are the x values. So I'm tempted to say negative infinity, to positive infinity. Someone, I forget it was Obi or Jeff, brought out an interesting point of how it does kind of look like there's a vertical asymptote here, because you see how this thing is just like rapidly going down. I think they would give us a dashed line to indicate whether that's an asymptote or whether it just blows up really quickly, and that's why it's off graph. Okay, here we have Obi's submission. Obi says this. Curious. Okay, cool. All right, the range. What do we do for the range? Right, domain describes all the x values. How do we figure out the range? What's the range? Oh, you can't? I believe. Yep. Good. Negative infinity to 4. Yes. Negative infinity, comma 4. Yeah. Perfect. Yeah, because that describes the y values. So the y values, this thing tops out here. The definition of an asymptote is that it can't go past it. It's kind of like a wall that it hits. So it tops out here. And then you always do things in domain, you do like from left to right. With range, you do from bottom to top. So some students will say, oh, it's 4 to negative infinity. And I'm like, uh-oh. You have to say it's negative infinity to 4. Always start with the lowest one. Good. All right, then how do we do the y-intercept? I hate when the emojis take over. 3? Yes, I agree. So y-intercept is where does it hit the y-axis? That's right here, which I think is between 2 and 4. I agree. That's cool. 3. And then what would the x-intercept be? Oh, very good. Yes. You know, you bring up a good point, Adarsh. Yeah, you should technically say 0, 3. When they want the intercept, they usually want the point. This is one of these, I don't know. It's annoying in math because we all know what you mean when you say that the y-intercept is 3. We're like, duh, yeah, x equals 0, y equals 3. But they want you to be rigorous. They want you to be complete. It's similar to spelling things correctly, which if Sensation were here, he would agree with. He's our spelling... I can't say Nazi now, though, right? What? He's our spelling fascist? Is that what I'm supposed to say? And good. X-intercept is going to be negative 1, 0. Yeah, perfect, right? Because that's where it hits the x-axis. Okay, cool. Spelling Mussolini. You spelled Mussolini wrong. Isn't it M-U-S-S-O-L-I-N-I? That looks like Mussolini. Do you remember reading this book when we were kids about, like, World War II, but they're rats? Or mouses? Or mice? You remember this? It's like Jewish people are mice or something? Benito? Okay. Spelling Benito. Yeah, dude, you know what I think? I think it's called mouse. One sec. I'm just gonna, because we're on the topic of, like, Actually, also, I think today is Holocaust Remembrance Day, isn't it? No, I'm wrong. That was last Monday. Okay. I'm getting my news from like what pops up in my Instagram feed. Okay, whatever. But yeah, the book is called Mouse. Yes, this was it. Yeah, this is it. Yeah. So wait, is Hitler a cat? Is that how this works? And like the Jewish people are mice? I don't know if that's actually like the best way to portray that, because that's two different species. Okay. That's in Japanese, is it? I don't know. Okay. Positive interval. That's just going to be where this function is positive. Oh, mausu. Well, they probably have it translated into different languages. I'm sure they do. Switzerland during World War II. What's this gift, dude? Yeah, no one invaded Switzerland. That's true. -1 to positive infinity. Exactly right, yeah. So from here all the way to positive infinity. And I think when they say this, you still want to use a parentheses, because technically it's neither positive nor negative at -1. Yeah. Oh, good job displaying 20 of the swastikas. Really? There's actually a lot of interesting again, swastikas weren't always like a bad thing. I mean, they've been used for like thousands of years. And it's actually interesting, a bunch of different cultures that have not had contact with each other, but were on different continents, all draw this symbol. And I think it's because it's the precession of the stars, is what it is. Yeah, the Indian, yeah. The Hindus use it for sure. They love swastikas, but no. Yeah, Hinduism and Buddhism. Oh, okay. Oh, the orthogonal ones were Buddhist and some other religion. But it's an interesting trend where a bunch of seemingly disconnected cultures were drawing the same thing. And I thought it was because of maybe how the stars are moving or something. Okay, cool. So if the positive interval is negative infinity, -1 to positive infinity, the negative interval is the rest of it. So that's negative infinity to -1. It's a hooked cross. Oh, okay, cool. Interval of increase. Well, that's just all of it, right? Because it's always increasing. It's like always going up. So this does not exist. This is going to be from -infinity to infinity. Okay, let's get to the end behavior. This is kind of the tricky thing that comes up. Interesting they do it like this. Usually how we would write this, this is cool. They're introducing you to limits is what they're doing. Because usually we would say the limit as f of x, the limit of f of x as x approaches in -infinity is equal to. That's the better way to write this. Yeah. But what is that? So what does this mean, guys? What does it mean when they ask for a question here, right? I like to always tell students that that's how they write it in college algebra now when doing asymptotes. They write it like this. This seems like coding language to me, or like, you know, like Python without the word limit. But yeah, this f of x, right? This is what I say is like the y coordinate, right? F of x. And then x is the x coordinate. So they're saying what happens to y as x goes to -infinity. So if I look at my graph, as x goes to -infinity, the y goes really far down. Maybe your next AMA. Yeah, dude, bro, that would be my last AMA. So yeah, this is going to be -infinity. Okay, but I like this one. Someone tell me what this. So now they have the end behavior as x approaches positive infinity. How would I write this one? Ooh, the poll ended. What were the votes? Ooh, 3 for that one. Good, 4.
Nice.
See, Raven, you're smart. You know math. Yeah, good. This is 4. Oh, no. Because, yes, as we go to the left, we try to get closer and closer to y equals 4. Nice. All right, last question before we have the graph duel off between our math chads. They're asking for the rate of change over -1, 0. How do we do that? I think sometimes you guys call this ROC, rate of change. Rate of change is the same thing as the slope. Yes, good. Find the coordinates. You're very correct, Adarsh. So I want the slope between these 2 points. And this is not a single point. This is an interval. So these are the x coordinates. So between the x is equal to -1 and the x is equal to 0. Rocketing in the USA. Yeah, ROC in the USA. Okay, so at -1, right? The y coordinate for that is 0. And at 0, the coordinate is 3. So I have -1, 0. And I have 0, 3. And now I just need to find the slope between these 2 points, which is just y2 minus y1 over x2 minus x1. So that's this minus this. 3 minus 0 over this minus this. 0 minus -1. That equals 3 over +1. So then your answer is just 3. And you can kind of see that. Yeah, good, Adarsh. Yeah, it's just 3. So between here and here, if I were to draw a straight line between these two, right, I would get this. This is kind of what we got. Yep. Yeah. So cool. Yeah, that's like an estimate of what the slope is in between these 2 points. Eventually, we're going to learn in calculus how if you bring, for instance, this point like closer to this point, you get an even more accurate representation of what the slope is at that instance, which is called the tangent line or the instantaneous rate of change. So you divide by y. Yeah, you divide delta y by delta x. So this is this right here is delta y over delta x. Correct, yeah. Or dy over dx. Yeah, delta refers to the change. Okay. All right, nice. That's a good question.
Good job.
Oh, I gave you 2. 1 sec. I can only give you 1. It's not bonus day. There you go. I accidentally gave you 2 points. You get 1 point. All right, let's try. I want to see who wins the graph here. Okay. So we're going from -10 to 10, and then we're gonna overlay it on top of it. So here we go. This is the graph. Let's pull up Desmos, and let's put some graphs in. So what did we have? Well, I gotta actually go see it first. Sorry, these were our okay. -2. Yeah, let me take a screenshot of this so I can see it somewhere else. Okay. So Endar, you're purple. Let's see if it'll let me change the colors. So we have -2 to the. Oh, it already does this. Yeah. -2x, and then we have +4. Okay. That's Endar. Can I change his color? Yeah. You're purple. Okay, Jeff was red. Jeff said 4 plus 6 to the -x over 2. Okay. Oh, you can't see the typing. Oh, yeah, one sec. I'll get it. And then, oh, I see, because it's up at the top. Interesting, it does that here. Can you see this now? Okay. And then this is -4, or negative 4 to the negative x plus 4. Wow. Oh, I see. Obi, you're cheeky. Obi wrote the same question as Endar. He just wrote it in a different form. I was like, why are they on top of each other? Okay, funny. Okay, so... And then here, let's change our... Well, no, this is fine. I'm going to change this like this here. 10 to 10 is okay. That's what I want. Yeah, good job, Obi. That's hilarious, Obi. Okay. So now if we go back to this... Go away, all off. And we paste it. Let's see which one it looks like. Let's see if they got close. That's what happens when I teach someone for 15 years. I feel you, dude. Okay. Okay, there we go. I wonder if I can, like, see it, though. I'd say it's pretty close. Like, here, if we, like... Let's bring this down. Make it so the things are the same. Well, oh, the scaling's not going to work then, is it? Yeah. Yeah, nice. Okay. Cool. Yeah, I think you guys are good. Jeff was off by a minus sign somewhere. It's okay, Jeff. We still love you. Yeah, cool. Good job, guys. All right, nice. Okay, I got a couple more questions. Ooh, last one's QV. Action commits Hirikiri. Dun, dun. All right, let me show my screen to you. My frame rates are gonna hurt. It's okay. Okay, let's see. F and G are defined by the following tables. Use the tables to evaluate the given composite function. Ooh, I love these. These are fun. I just want to make these bigger. Make my life easier. Yeah, Femvox is ready. Femvox is like jumping on the gun. Okay, cool. All right. So they want F inverse of G of 8. So when this happens, QV, I want to first figure out what G of 8 is. And the way to do that is to look at our table here for G. So G of 8 means what is G of X when X equals 8? That right here is -2, okay? So now I can replace this whole thing with -2. And we're figuring out what the F inverse of -2 is. So good question. Do you know what this means when we say F inverse of -2, QV? Okay. I'll explain it to you. Okay, so here's what happens. So F of X will give me a Y. But F inverse of Y will give me the same X. So what I like to say. So like, see how here we put in like X was equal to 8. And then we were given out Y was equal to -2. F inverse of a number is saying if Y is equal to this, what is the X equal to? That gets me this Y. So for instance, F of 8, or sorry, G of 8. G of 8 gave me -2. But G inverse of -2 would give me 8. Does this make a little bit more sense? Inverse is like the reverse. It's the reverse direction is what it is. So when they say f inverse of negative 2, they're saying, what is my x, right? What is this? Such that when I operate on the function, I get this. So what does x need to be in order for f of x to be equal to negative 2? What does my x need to be with the f function such that the y value is negative 2? That's kind of what they're saying. Four. Yes. Exactly, dude. Yeah. So see here, right? Yeah, because when this is negative 2, x is equal to 4. So yeah, this is just equal to 4. Nice. Mm-hmm. If you want to see something really cool, just real quick, just so I can show you. Inverse functions kind of like cancel out regular functions. So let's say, for instance, we had here, right? F of 1 was equal to 5. What would f inverse of 5 be? So if x is 1, y goes to 5. F inverse is saying, okay, if y is 5, what was my x? Well, we can look here at the table, and we see that, yes, if y was equal to 5, then x is equal to 1. But let's remember, 5 is also the same thing as f of 1. So you can take this and just plug it in. And now you get, okay, cool, f inverse of f of 1 is equal to 1. This is a very important property with inverses and regular functions, is that the inverse function of a regular function of x is just equal to x. And the same thing where the function of the inverse function of x is all equal to x. Why don't we just call them x or y? That's a very good, very, very good point, Raven. The reason why, to not say why again, is that provided the f is invertible, correct. So when we talk about functions and we say x and y, we're talking about the x coordinate and the y coordinate. But what if I have another function that I'm looking at as well? So in this case, I had another function g, right? If I call this x and I call this y, this is another set of x's and y's. So I can't really call this also x and y, because then I don't know which one we're talking about. So what they end up saying is that this one is f of x and this one is g of x. Yeah. You are right. So whenever you're just dealing with one function, I tell students, if you're confused, remember that f of x is just the same thing as y. Okay? But if you have a graph, and you will have this in later math classes, where you have two functions, so let's say for instance this is f of x, and then this is like g of x, we need a way to distinguish which y value we're addressing. Like, am I addressing the y value here or the y value here? If parent and child are inverse functions, how come your parent's child isn't always you, bro? Your parent's child isn't always you. I feel like that's a math joke I don't necessarily understand. There's always these funny things with like family trees where you can somehow have that you're married to your grandpa or something, right? It's my brother's. Yeah. So the other cool thing about this is that inverse functions acting on functions kind of strip them away. So they get rid of this and they free this variable. They free the x. This is why, and I'm going to make a video on this because this comes up all the time with inverse trig functions. People don't understand it. They lose their mind. Let's say, for instance, you had that the sine of 45 degrees was equal to the square root of 2 over 2. Okay? This is an expression, right? We know that if something is a 45-degree angle, the opposite over the hypotenuse is square root of 2 over 2. So we could have had it be this. Okay, sine of 45 degrees equals x, right? How do I figure out what x is? I just do the math here, okay? But let's say, for instance, you were just given the ratio, but you weren't given the angle. Okay? So you were told that the sine of some angle is equal to the square root of 2 over 2. How would you figure out what this angle is? Some students try to say, oh, I can just divide by x. That is wrong. You can't, or like divide by sine. Like, you can't divide by sine. That's not a thing. There's a massive chess drama going on. What, in my server? Oh dear. Okay. What we can do, however, is take the inverse. Oh, IRL. Oh, okay, cool. Is it with Magnus again? Yeah, Magnus refuses to wear jeans. Magnus just knows he just can do whatever the fuck he wants because he's like the face of chess at this point. And he's got the rep. Yeah, he told him to resign. Wow. Oh, okay. But anyways, what happens here is inverse of a function, remember from this, right? They destroy each other. This goes away. And you're just left with x. And now you get, oh cool, x, the angle I was looking for, is equal to the inverse sine of square root of 2 over 2. So this is the arc sine, is what we say. So this is why we use these sine to the negative 1 things. And it's not 1 over sine. That's not what this is. It's called an inverse function because it takes the ratio and spits out the angle. Whereas a regular sine, like sine of square root of 2 over 2. Or sorry, sine of an angle, let's say the sine of 45 degrees, would give you a ratio. As long as they're good inputs, correct. Yeah, an arc sine is actually defined in certain domains and stuff, so yeah. Correct. Yeah, OB is correct. Yeah. Yeah, because of how and this is where what they'll do is they'll give you this, for instance, but then they'll tell you what quadrants it's in. Or they'll say and the cosine is this. They'll say, okay, right. They'll say like, ooh, the sine of x is equal to square root of 2 over 2 and the cosine of x is equal to negative square root of 2 over 2. That's a way to determine it. Because you're right. There are a lot of angles where the sine of it is square root of 2 over 2. You know, there's this one and there's this one. But then the cosine being negative knocks this one off. And then says it has to be this one. Exactly. Yeah, you're right. And I've been over this on other streams before, like why that is. But we define arc sine to be only in these two quadrants. Or what the output values you can give. Just to ensure that it's a function, because functions for a given x can only output one y. They can't output two different y's. Yeah, nice. Cool, good question there, QV. I like it. Nice.
Well done.
Okay, sweet. Looks like we're good on questions. We did all the questions today. I'm happy. Yeah. Okay, cool. If that's the case, I'm going to take some time because I got to teach another student in an hour and I want to eat dinner. So I'm going to go eat some dinner. Let's end out the stream.
That's dope.
Thank you everyone for coming to office hours today. A lot of fun working with you guys. Appreciate all your inputs, comments, content, questions. A lot of fun stuff. I love learning with you guys, and I hope you guys do too. So, okay. appreciate that. Yeah, so the next stream will be tomorrow. That's Tuesday at an hour later, 4 p.m. Pacific, 6 p.m. Central, 7 p.m. Eastern. So come on by, get help with math or science. You can join our Discord using the link over there. And if you ever want more math help, we have a wonderful list of streamers that help us out. And Tuesday... No, this is what you do. Watch what you do, Shantrix. Tuesday. Tuesday. Yeah. Okay. So yeah, come on by for that. We'll have a good time. Let me see. Let's go raid somebody. Who else is streaming today? So yeah, what I would do, right, is if you use the calendar command, I could go see like who's streaming, which we're the only ones today. Totally cool. I know Penn said they need a little bit of a mental health day. Mental health is important. But tomorrow, make sure you go check out Zach has an Infinite Series stream he's doing tomorrow, about an hour and a half into our stream. So awesome. And then Penn Center still has his linear algebra on Wednesday. Cool. And I've been talking with him. We're gonna do some cool developments with things coming up in the next couple weeks. Anyways, so let's go raid somebody. Bro, what are my recommendations right here? Birthday counter, slumberthon, love acceptance, and free the Pgina. Okay. VTune. Okay, now I'm mad. Trash TV. Please don't support me. Like, bro, what is this? Yeah, it's like a furry VTuber. So I always click following because the recommendations Twitch gives me are absolutely garbage. And sweet. Okay, let's see. So high potential's off, doing some really weird stuff. Globus is doing big AI in Japan. AI thieves deep research. Rate of VTuber. No, I don't want to get into, because I have students, I have kids on this stream. I can't send them to a furry. Or Microscope Monday. I try to follow everybody. Also, please let me know if you have other math or science streamers that you find are cool and you want me to maybe raid them. Like, send me their handles. I'll follow them, and then if they're online, I'll raid them. But okay, microscopes or AI in Japan. Do you want to go to the Wizard? You want to go to Globus? He's a cool guy. He may be finishing his stream soon, so let me make sure he's not going away yet. Okay, cool. Yeah, okay, cool. All right, let's go raid Globus. He's a fun guy. I love his cat. Okay, cool. All right. Thank you, everyone. We will see you guys on Tuesday, an hour later. Enjoy the start of your week. Have an awesome Monday. And we'll see. And yes, Famish, DM me. I'll send you the book. All right. Peace.
Resistance is futile.
What up, Raiders? What up, actual education? What up, Shantrix? Welcome in. For those who are new, I'm Globus the Elder. I talk about AI, automation, robots, and future tech, and I do my best to help prepare you for the changing world as it currently exists. We are currently watching a video related to deep research, which just dropped from OpenAI, and its capabilities as a reasoning model. This is brand new, hot off the presses, big stuff, happening today kind of vibes. So, get your drinks, get your snacks, have a seat, and let's learn.
Out because the model relentlessly asks me questions instead of actually answering the question. Now, you could say that that's actually a brilliant thing, because any AGI should ask you clarifying questions.